Phosphorus is one of the essential elements of living organisms and is found within them in significant quantities. It participates in the formation of biological membranes, nucleotides, proteins, phospholipids, and other cellular structures. The reserves of phosphorus accessible to living beings are entirely concentrated in the lithosphere. The primary sources of inorganic phosphorus are igneous rocks and sedimentary rocks, particularly phosphorites. Mineral phosphorus is a rare element in the biosphere. Its content in the Earth's crust does not exceed 1%. Inorganic phosphorus enters the cycle through the dissolution and leaching of rocks from the Earth's crust. It reaches terrestrial ecosystems and is absorbed by plants, which, with its participation, synthesize various organic compounds. Phosphorus then passes to animals through food chains. Subsequently, organic phosphates, along with the remains and excreta of living organisms, return to the soil. There, they are acted upon by microorganisms and transformed into mineral orthophosphates, once again ready for uptake by green plants and other autotrophs. Flowing waters bring phosphorus into aquatic ecosystems. Rivers continuously enrich the oceans with phosphates, which promotes the development of phytoplankton and organisms at various levels of aquatic food chains. Absorbing all the transformations of phosphorus on a biosphere scale, it becomes apparent that its cycle is an open one. This is because this element doesn't form volatile compounds that could enter the atmosphere. While in terrestrial ecosystems, the phosphorus cycle occurs under optimal natural conditions, this is far from the case in the ocean. This is due to the continuous deposition and accumulation of organic matter on the seabed, particularly phosphorus-enriched remains of fish not consumed by other aquatic inhabitants. Organic phosphorus that has settled in the tidal zone and in shallow waters can be returned to the cycle through caught fish or via the excrement of birds that feed on fish and marine organisms. However, this doesn't apply to deposits on the deep sea floor, which occupy about 85% of the total ocean area. Phosphates that reach great depths are removed from the cycle for tens to hundreds of millions of years. Humans replenish phosphorus deficiency in soils by applying phosphate fertilizers. However, an excessive phosphorus content is harmful to plants. Wastewater from industrial enterprises with a high concentration of phosphorus can cause water pollution and the death of plants, fish, and birds.